So we don't have as much time for kaggle tricks as I would like, but I do want to just give you like at least one, well, really two. Here's one that you can do directly. So when you look at the data frame, and you have the count, which is what you're trying to predict, you could actually take the mean count of, like, say, each season. And you can use that to help predict the overall count. Now, it might feel like, no, wait a minute, is that cheating? Because if you're going from the prediction back into the data, that's something that you're not supposed to do. But season has these different values, 0, 1, 2, and 3. And we can assume maybe that the mean counts will be the same regardless of what the individual prediction is. So in effect, it's almost like replacing or really adding another column to parallel a season that'll give different numbers. And you could actually do this for any column as well. And so this has been reported to have, given really nice results in kaggle. So let me just show you one way you could do that. Well, if you put in df season mean, okay, that's I'm trying to create a new column called the mean of the season. It's the mean count. So what you do is you group by the season, right? And what that does is put all seasons together. But then we've got to pick, like, well, what are we going to compute? What this means is it's going to take the mean of the count column. So for all the seasons of 1, it's going to compute all of the, it's just going to take, like, all the counts, like, which is the number of bike rentals, it's going to give the mean of them. And so if you want to see what the result is, just run that line of code, and then it can work to do it by, like, different rows. Like if you like a df iloc and say row, well, we can start with row 0, and then all columns. And then if I run that, you can see here we've got season 1. I've got a new column which gives 2604 as the mean. Now see the count here, it's not the mean, but the idea is that the mean can help you predict the count. Okay, if you compare that to 100, season 2, you get a mean of 4992. Season 2, you get a mean of 5644. Season, we'll keep going up if I count by hundreds. Yeah, season 4, 4728. And to show you that it should be the same across all the same seasons, like if I try theory of 5, am I still in season 4? And yes, the bottom number is the same, even though the count is in fact different. So I encourage you to try this to improve your scores. Okay. And, I mentioned about the non-correlated ensembles. The reality is it's a lot of code, and it's really designed for classifiers. So if you just look here at this hands-on gradient boosting with XGBoost and scikit-learn GitHub page, this is in chapter 9 of the book. And if you go up into the Kaggle winners IPython notebook, it starts with this Cabrides data set. And I can tell you, by the way, I'm just going to scroll down through some, it's called feature engineering, by the way. It's not something that we focus on. It's like, you can think about, like, how can I make new features? And actually, this is the type of thing that can work in your data set. If you have a timestamp, can you extract the hour, the month, etc. And so you can do frequencies. Frequencies are basically like the total numbers of, right? So these are the cab types, and you can just, this is like what we just did. You just, if you divide by the length, it gives you what's called the frequency. That can be great for data sets that are slightly different. So really what this feature engineering is, that's ways of tweaking the columns that can be advantageous for machine learning that have been proven actually in Kaggle competitions to do so. This is the same thing as what we just did. It actually didn't work for whatever reason in Colab to import this. And then here we get into the one I wanted to talk to you about now, which is the non-correlated ensembles. And so the idea is this, look, let's just, you already know about this first part. You're kind of like checking different models. XGBoost, by the way, you can do different boosters. They can give you different scores. Okay. Like GB linear compared to Dart. I think Dart is the default one. Or maybe it's not. It's something similar to Dart because that's a different score. And so basically you run a bunch of different models, and then what you do, you want to get the predictions from all the different models. And here you can see the different predictions, okay? These are different accuracies. Now, this is where the correlation comes in. Okay, so this code right here. You can actually put all this into a data frame. Okay, it's kind of fun. So what you're doing here is you're concatenating. It's a NumPy np.concatenate. You're basically combining, hey, all the predictions, okay, with the columns. Okay, so look, this first column, GB tree, it gives you, but now I'm looking at it. See, concatenate is special. Like GB tree, I'm sorry, because we're getting the correlations. Okay, my fault. This is not just the data frame. This is the correlations, okay? So basically, right, these 4 columns, each of individual values, are looking at how well correlated the values are. And so the idea would be this. If you have like a bunch of models, you can create your own ensemble from these models. And what you can do then, see, if I analyze this, I would say, well, if I look at GB tree, I can see that, or look at the XG boost maybe that's the default. And so I can see that, well, look, forest and logistic, even though they're getting like predictions that are different, whereas Dart and GB tree are very highly correlated. They're almost giving the same predictions. So if you're combining different models, really your advantage is to combine with models that give different predictions, because it's only going to be wrong if they all give the wrong prediction. And so basically here then is code for choosing different models. And by the way, you could do this without the correlation, okay? You choose different models, okay? And you basically append them to a list, which here is called estimators. And you're giving them a name in the model itself. And then at the very end, you can put them all together and say a voting classifier in this case. Okay, and so it's just a way to really combine code to then try to improve upon your scores. Okay, so I just want to leave you with, again, it's a lot of code. I don't want to like parse through all of it with you now because, you know, this is kind of it's at the end of the class here, but I do want to give you some ideas of different things that you can look forward to improving upon and looking at yourself. And again, this code is simply in the Hands-on Gradient Boosting with XGBoost and Scikit-learn GitHub page under Chapter 9, kagglewinners.ipynb notebook. Thanks.